Hello and welcome to India Career Center, the one-stop podcast for students, professionals, parents, and guardians. In every episode, we will try to deal with a current topic that needs expert advice related to career guidance, and career mentoring. Please welcome your host, Dr. S.P. Mishra, to the show. And happy listening.
Welcome, ladies and gentlemen, to one more episode on India Career Center. Today we have a very interesting topic in our hand. To start our discussion, I would like to give a brief about why it is so important. What is the basis of this important topic? Recently concluded meeting at Glasgow, this COP26. In that, India made commitments that by 2030, about 500 gigawatts of energy will be generated through non-fossil method. India will, use 50% of energy through renewable resources. India will reduce at least 1 billion tons of projected emissions between now and 2030. India will reduce country's carbon intensity to less than 45% by 2030. And India has committed to become a net zero emission country by 2070. Now, these are all very bold targets for India and all other countries, especially the developing countries. So the move towards becoming net zero emission is going to require a lot of investment in the renewable energy development. And that journey is already started. Now, in the renewable energy sector, there are two primary components. One is the solar energy, the other one is the wind energy. Now, solar energy and wind energy have their own pluses and minuses. Solar energy obviously can be only generated when the sun is out, which is during the daytime, and the requirement of energy will be required throughout the day. Similarly, wind energy may have its own challenges. At all point of time, the wind may not be similar, so there'll be fluctuations in the production. Whereas the energy requirement of India as well as across the world, I mean, India has about 145 crore people, and the whole world is having approximately about 750 crore people. And it is estimated that by end of this century, the population will grow to about 1100 crore. So which means that a lot of energy will be required. At the same time, we cannot keep on emitting the carbon into the atmosphere. So for the renewable energy to become successful, we have to also have technology for storing, and that is where the concept of battery comes in. And to discuss more about this, the technology about battery, we have an industry expert today, Mr. Ramesh Natarajan, who has been the director in Unit Techno Systems Private Limited, a Pune-based company. Mr. Natarajan has been in this field for last more than 40 years. He has written a very wonderful book called The Batteries Demystified, which I think is an excellent book for not just starters, but also for experts in the industry. And to discuss more about this and to learn more about the batteries, I now welcome our guest today, Mr. Ramesh Natarajan. Mr. Ramesh, welcome to the show.
Thank you, Dr. Mishra, for giving me this opportunity, welcoming me to your show. Now, I grew up and finished my education in Bombay. At the age of 20, after my graduation, I shifted to Goa. I was there for 10 years. I learned everything about batteries, working myself there, and hands-on experience. I gained a lot of hands-on experience in Goa. After which, after 10 years of working in Goa, I shifted to Pune And actually speaking, my dad is also from this industry. He was the general manager in Standard Batteries in Bombay, and that's why my education and my schooling and everything has been in Bombay. He was the GM engineering division in Standard Batteries in Bombay. He worked for 33 years in this industry, and after which, since 80, I have been working in this industry. The last few years, when I had set up this factory, Unique Techno Systems Private Limited, it's a family concern, and me and my brother, we've been making batteries for motive power, that is mainly forklifts and all that, and also for the golf carts and scrubbers, sweepers, material handling equipments, platform pallet trucks, and all these vehicles which are used in the airports, the docks, and ports, as well as large industries, especially the food and chemical industries, where you cannot use an IC engine or a diesel-operated forklift or any vehicle which is consuming petrol or diesel. We also have been making machines for the battery industry. So these machines are machines to make automotive batteries, motorcycle batteries, inverter batteries, and all the other lead-acid batteries, which are also made by many manufacturers, other than the established few names of which almost everybody know. But there are very many industries all over the country. You won't believe that there'll be something like about 40 to 50 industries making batteries in Pune itself. So you can imagine there are many in all these cities like Hyderabad, Ghaziabad, Delhi, and all these places also, and all over the country, like East, West, in Gujarat, and all these places, including Kashmir. And we have sold machines to people right from Kashmir to Kerala, to Tamil Nadu, and also in Assam, also in Gujarat, and all over the country. So you can imagine how many battery companies are there. Battery is a very essential part of our lives because we store energy in batteries, and a lot of batteries are used in industries also. Even in these IT industries, you have big UPS systems, and also in the continuous process industries for UPS applications, and for material handling, of course, also. And we also use batteries in homes. During this process of 42 years in batteries, I have designed batteries for various applications. Like I've mentioned in my book also, the batteries for inverters are different from the batteries which are used for automotive batteries, automotive applications. And the batteries for forklift applications are again different compared to the batteries which are used for inverters. And similarly, there are batteries used for solar photovoltaic applications. They are different. Batteries used for railway signaling and railway air conditioning are again different. When I say they are different, what happens is the basic chemistry remains the same. The positives are lead dioxide, the negatives are sponge lead. But what happens is either we are changing the volume of electrolyte, or the type of plate, or the thickness of plate, or the construction of plate. In an automotive battery, you use positives are also pasted, the negatives are also pasted. In the case of stationary or traction batteries, the positives are tubular kind. So the plates are of a tubular type, and the negatives are pasted. Again, when you use for solar photovoltaic, you have to put a lot of electrolyte. The electrolyte volume per kg of active material is much more in a battery which is used for solar application. So I've been designing all these batteries also for various applications, and I've of course done a lot of seminars, webinars, and all that all over the world. Well, that's it. Introduction about myself.
Okay.
Yeah.
So the different types of battery which you mentioned, obviously every battery design is different for different application.
Yes.
So as I see it, the applications which are going to grow rapidly, of course, all will have a growth. There's no doubt about it.
Yes.
But definitely the way I look at it, the requirement for solar energy-based storage batteries, that is going to grow substantially, because more and more investment will happen in the solar industry for the renewable energy storage. And also we see that the movement towards electric vehicles, that is something which is also rapidly growing. So These are the two big growth areas which I see it. Now, just to take one at a time. So as per the COP26, India will have 50% of energy from renewable energy, which means that there will be large scale requirement for investment in the wind and solar energy generation, and similarly for very large investment in the storage of energy.
Yes.
So how do you see this from the point of view of the battery manufacturers and as a specialist from the industry?
See, as of now, there has been a lot of investment and a lot of talk about EVs, and EVs are coming up in a very big way. Now, these EVs need battery, electric vehicles. Now, what happens with the lead-acid battery, though it's a very robust, proven, and safe technology and all that, unfortunately, the lead-acid batteries cannot be charged very fast. They are very heavy. We cannot do opportunity charging. Opportunity charging means you use it for a little time and then charge it and then again use it. It's considered as a cycle, and the life does go down when you do opportunity charging with lead-acid batteries. And additionally, one more thing is you're going to get less mileage. And then there is also a maintenance factor which is involved, because you need to top up with water, you need to equalize the gravities, you have to monitor the voltages, and all these things are there. And these batteries are very heavy. So because they are very heavy, being lead, what happens is the mileage also comes down further. So because of all these reasons, though the EVs did start with lead-acid batteries initially, with the advent of lithium-ion batteries, that has been the preferred source of energy for these EV batteries. So people have moved into lithium-ion. I'm not saying that lithium-ion is going to be the final and the thing which is going to last for very long. I'll explain the reasons as we go along. But till any other technology comes in, like whether it's a sodium ion or aluminum air or hydrogen or something else which comes to replace lithium ion, we are seeing a lot of vehicles coming out with lithium ion batteries. Okay. In this also there are two types. One is lithium ion with the NMC technology, and one is with FePO4, that is ferrous phosphate. Now, both these are being used, but more so ferrous phosphate of late. And because it's comparatively safer compared to NMC, comparatively. But anyway, there are problems with that also. But whatever it is, lithium ion and EVs have come in, and there are a lot of vehicles all over the country, in India and probably around the world also, with these batteries. Now, batteries as such can only store energy. They cannot be giving off energy endlessly. When we have these lithium-ion batteries which are used, and after it has been totally discharged, you've got to charge them. Naturally, if you're going to charge them, there is no abundant electricity available. In fact, now you see there's a power shortage, and we are facing problems all over the country with the power cuts and everything. So what is going to happen is we will have to go to some source like a renewable energy only, which is abundant sun, which is available in India, or wind power. In a tropical country like India, solar is more preferred. There are more solar installations compared to wind energy. And so solar power is going to be used. That is where I see a lot of investment as well as development and a lot of career growth opportunities for people who are specializing in renewable energy. So now this solar energy is available only for about 4 to 6 hours in a day. Again, its peak available only around 2.5 to 3 hours. So definitely this energy will have to be taken and stored. Now lithium ion, even if you're using it in the vehicle and throughout the day if you're using it and the evening to come and charge it, you will not have sun available at that time. So that energy will have to be stored in the most proven technology today is lead acid. It has been stored successfully over so many years. Wherever solar energy has been used in remote areas like Leh, Ladakh and all that, where we don't have the grid power and all that, it has given 10 to 12 years of life also, all these batteries. And it is proven, it's known. Okay. Now there are certain reasons why it's lasting for 10 to 12 years also, these batteries, because the depth of discharge is less when you use it for solar application. These batteries are made specially with the autonomy of about 4 to 5 days. What happens is these batteries are discharged for 20% depth of discharge. they are made in such a manner that even if there are 4 or 5 sunless days with continuous rain, the battery has to still give power. So lead acid battery has proven itself in solar applications. And so what I feel is there will be a lot of lead acid batteries which will be required for solar applications, where people will be storing the power and using this power to charge the lithium-ion batteries in the evenings. So this is one area where there's going to be a lot of scope.
Fantastic. So I mean, so basically, there is an interdependency of two different type of technology, and they will have to live together. That's how you see it.
That's what I feel, and that's because there's no way that you will be able to. Of course, there will be some lithium ion also which will be used probably to store the solar energy instead of lead acid battery. Yes, it's possible, but then lithium is not available to such a great extent. It's not recyclable as of now, and there are a lot of hazards with mining of cobalt and everything also. So I feel they will restrict the use of lithium ion or the availability of lithium ion, and the cost factor of lithium ion being so high. It will be used more where it is absolutely required, where they want a lightweight battery which can take opportunity charging, which will charge fast and all that in the electric vehicle. But for storing, I think people will prefer lead acid battery. That's what I feel.
Okay. So now coming to the requirement of the raw material, which is for example, in case of lead acid, obviously lead is one of the important component.
Yes.
How well are we placed as country India for this raw material?
See, you mean for lead acid or lithium ion?
For lead acid.
For lead acid, we have no problems.
Okay.
All the batteries which are made, whether it's an automotive battery, motorcycle battery, stationary inverter or a UPS battery, or a stationary solar photovoltaic battery, or the motive power traction batteries, all these batteries are recycled. They go to these authorized smelters who, cut open these batteries, break it open, remove the polypropylene container or the MS crate in the case of traction battery. They remove it out. They take out the lead, and generally about 60 to 70% is recycled. And that 60 to 70% of the portion of the battery is a substantial portion. It's almost 100% of the lead which is taken out and recycled. The parts which go out are, a bit of containers, the plastic covers, the plastic containers. Then there are some plastic components inside which are used as side packing or prisms, which are the only things which are taken out, and polyethylene or PVC separators which are used in the battery. But the balance, entire lead which is there, is totally recycled and reused. So there's no problem as regards raw material for lead acid batteries. When it comes to lithium ion, what happens is lithium is mined only in Argentina, Bolivia, and Chile. So these are the two places. There are a few lithium mines in USA, Australia, and China. But cobalt, which is required also for these lithium-ion batteries, is mainly in Congo. And in fact, a lot of children are used, is what is reported, to mine these. And it's not mined in a very safe manner, is what the reports say. So lithium is not available in plenty all over. So making lithium-ion batteries is not very easy. So that's why I see a lot of scope even now for the lead acid batteries.
Very clearly, the two different types of battery concepts will continue to be there. As you also mentioned earlier, that new development which happens, which can replace the current battery technology. Till such time, I think we will continue to depend on these two major battery technologies. One is the lead acid, the other one is the lithium ion. Now, what I would want you to also focus on is that battery as a technology is going to grow further because we are depending on this for various things. So what, as an industry expert, you would like to explain about, of course, you did touch upon what are the various opportunities which are there. But if we can discuss a little more about what are the different areas of opportunities in terms of the occupations for the future related to renewable energy, related to battery industry, related to, post usage. You mentioned about the recycling of battery. So what are the various opportunities which are there related to this industry? If we can discuss a little more about this.
Yeah. See, when it comes to EVs and EVs which are fitted with lithium ion batteries, what happens is lithium ion batteries need something known as a BMS. BMS means battery management system. So battery management system is something very unique in the sense that it is not a requirement when you're using a lead acid battery, but when you're using a lithium ion battery, it becomes imperative and compulsory that you have to use a battery management system in conjunction with a lithium ion battery. Why so? Because a lithium ion battery, they are a series of cells which are connected, and none of these cells are supposed to go beyond a certain voltage, either when you're charging or when you're discharging. You have to be very careful, because if you exceed the maximum voltage, the batteries can explode or catch fire. Similarly, if you over discharge also, they can be dangerous. So this has to be managed very well with the use of a battery management system. Now, only measuring these two things are not important. You have to ensure that the temperature doesn't go up. You have to ensure that the electrical resistance of the individual cells are also within the tolerance limits, and the resistance also has to be monitored. So all these things need to be monitored and controlled with the battery management system. Okay. Now, in case these are not monitored, or there is a fault in the battery management system, or something happens where the voltage goes up, or you're deep discharging, there is a possibility of a thermal runaway, because of which the cells can ignite. And one cell, if it gets heated up, it heats up the next. And similarly, these things spread and cause a fire or an explosion. So the lithium ion battery needs a battery management system. So a lot of people have started developing these battery management system. So there is a lot of scope there. Okay. There is a lot of scope for people who are making chargers, which are specific for this. So you have chargers, charging stations, battery swapping, which is coming up in a big way for these lithium ion. Because if somebody is traveling, say from Bombay to Hyderabad, and if he reaches somewhere and he wants to charge the battery at the service station, so he needs these charging station. But if somebody doesn't have the time even for that, then he thinks of leaving his battery there and connecting another battery. So you have swapping stations also coming up in a big way. So there is a lot of infrastructure which is being developed for battery charging stations, battery swapping stations, and battery management systems which are required, the chargers which are required. There's a lot of scope there. Now, with a lot of these things, there is also a scope for supply chain and logistics. In that segment also, I see a lot of growth. And like I mentioned, renewable energy is going to come up in a big way. So people who are studying these segments, people who are specializing in renewable energy, people who are specializing in chargers, and all these people are going to have a lot of scope in the future, is what I see. Now, when it comes to recycling, like I mentioned, if you're going to have lead acid batteries also growing, the segment in lead acid batteries also growing for the storage or for renewable energy, then the pollution norms are becoming stricter too. And for recycling, environment, safety and health, all these people who are connected with lead acid batteries, they will also see a lot of scope and growth. So these are a few segments which are going to be very much in demand. Another thing is the lead acid battery by itself. There are very few companies, maybe you say about 6 or 8 companies, which are in the large scale segment. But there are hundreds of companies in the small scale and medium scale in lead acid batteries. Now, there is a lot of scope for people who are in artificial intelligence and robotics who can work with these small industries to automate certain operations and make these industries very efficient. So if anybody wants to do that, they can do that, because there's a lot of scope for people to bring efficiency in batteries in these segments. Then one more thing what happens is, in the battery industry, the investment in capital is not as much as the investment in inventory. If somebody has got a certain capital and he wants to set up a battery industry, he can easily set it up, because you don't need a lot of machines to make batteries or a lot of complicated machines to make batteries. But the investment in terms of raw material is very, very high. So we see that people set up industries, but then they find a lot of problem in getting working capital, or even if they've got the working capital requirements, the managing the working capital is a big hassle, because they have to work on inventory management. So if somebody can do some work on ERP for these industries in a manner that it can be standardized, and the industry can become more efficient because of this ERP, and it can reduce its working capital costs, then this is also one segment which can be looked into. So basically, all these small and medium industries in the battery segment, they have to become more efficient, they have to become more agile, and then only they'll be able to survive. Otherwise, it's very difficult for the entrepreneurs or the industrialists to survive in this segment.
So do you not see any kind of consolidation of small scale industries with the bigger brands?
See, the small scale industries are mostly either family run, or one industrialist or one person has put it up and he's still struggling, and he's still trying to keep it running. Now they are too small for the big industries to take it. The big industries will only finish them off if they don't become efficient, or if they don't become nimble, and cut costs in various areas of operation.
Mm-hmm.
So I don't think any big industry would want to take these small industries. There are a few medium scale industries who are using these small industries as their vendor.
Oh, okay.
They are buying from these people and
Rebranding
rebranding it. But then again, they are only rebranding, or they are able to put their name only on industries which have a good quality.
Right.
And again, when it comes to rebranding, again, they are squeezing the margins from these people. So that only makes them, they
So
will
these
have to become more
smaller industries are actually not in a great shape.
They are not in a great shape. Many have closed, especially post-COVID. Many have gone out of business, and the few which survive are also finding it very difficult to survive. So they have to become more efficient.
Okay.
How do they become more efficient? With better management of inventory, with a better quality, with automation wherever possible. Not automation of a scale where they can make millions of batteries. They are doing only thousands of batteries. Okay, within the 1,000 also. That is why I said, if somebody is able to do some small automation or robotics for these people, and retweak the machines which they already have.
Okay.
So that is why there is a lot of scope for young boys and girls who are ready to work on doing this, and they have hundreds of industries which will go for these whatever they do, any small automation.
Mm-hmm.
There is a scope for them to come in and do it.
Okay, I think the way I look at it, the battery industry, if I talk about the big ones, I think one of
Yes.
their primary cost of operation would be the logistics cost, because the batteries are quite heavy and voluminous. So for
Yes.
them to move around these material, the finished good across the length and breadth of India, that would be one of the major cost. And the distribution network which they depend upon, they will be also heavily invested upon in terms of the stocking, which you mentioned.
Yes.
I think the finished goods stocking, that also is a major cost if you look at it from the point of view of the overall industry. So if there is a possibility that the small and medium scale industries can collaborate with the bigger industries and come to a level of right kind of quality, then there is a possibility of reduction of this cost of logistics to a large extent.
What happens with the big industries is they have set up plants all over. They have one south plant, a north plant, a east plant, a west plant, a plant near a OE consumer.
Okay.
So they have plants all over the country, one. And even if they have something which they don't have in a certain plant, they are putting truckload of material and shipping it to that plant or that area. Whereas the small industries don't have that sort of a, one particular distributor in an area may not buy a truckload. He may say, give me some 30 batteries, 50 batteries. So it goes as a part load and it adds to the cost. So that is why the inventory management within the plant and the ERP which is required within the plant to plan the production and see that there is no excess of one particular type and there is a proper planning of production and planning of inventory and stock keeping and everything. This needs to be done for the small industries. The small industries operate within a certain radius. They say, okay, I can ship batteries only about 150 to 200 kilometers from where I am. And that is how they are operating and they are surviving and they are doing well. I'm not saying they are not doing well, but they will have to become more efficient.
Okay, great. I think any young listener or viewer who are seeing this program, you can actually reach out to Mr. Ramesh and take his wisdom of 40 years if you are planning to set up your own unit in any related battery industry, or you want to improve the efficiencies in any process. I think he has all the knowledge about.
They're most welcome, and they can avail of whatever they want from me, and we can work together to do something for the industry.
Fantastic. I think that would be required because the journey towards renewable energies has begun already. So we have to only go forward, which means that more and more work has to be done in this industry, and which means that more younger people need to come into the industry to make it more efficient, more profitable, and more accessible, I would say also. Because I don't think the renewable energy will only remain in the cities and towns. It has to also go to the smaller villages and municipalities and things like that. So that process of spreading across the length and breadth of the country will only happen more and more as we go along. Now, you touched upon the raw material which is required for the battery industry. So very clearly, lead as a raw material is very much available in India, which I assume about 94% of the India's requirement is available within India itself. The other challenge is with respect to the lithium-ion battery. I think for which India doesn't have any raw material which is available, and we are solely dependent on outside India sources. So, what are these challenges we face as an industry, and how you see that as an expert from the industry in terms of solving that problem? Because our dependence on that will only increase; it is not going to reduce. So how?
Yeah, if you are going to depend on lithium ion, like I mentioned, lithium is available only in Argentina, Bolivia, and Chile. And cobalt, which is required for that, is available only in Congo, mainly. And it is being mined reportedly. They're using children also to mine the cobalt, and it's a dangerous thing. And there is some lithium available in Australia, USA, and China too. But then it's not available in India, at least in the quantities which we require for making these lithium-ion batteries and all that. So now that is a major problem. So we don't have a problem for lead-acid battery recycling. The only problem is with respect to environment, safety, and health, which I mentioned. So if they have good pollution control equipments and effluent recycling plant, the lead acid batteries can be recycled safely, and it is being done for years now. In the case of lithium ion, what happens is there is no known effective recycling method, and we only hope that it doesn't go the way of the keyboards and the printers and the CDs and all, which we are not able to recycle now. All these things. So lithium ion, maybe 4 or 5 years down the line, I hope it doesn't happen that there is no effective method of recycling. And again, if at all there is a method of recycling, it has to be all over the world, because these batteries will come out from all over the world. You can't say, okay, we have a recycling facility in USA. Then are we going to send it? Is it feasible? Is it practical and financially feasible to send it all the way? If you have some recycling facility, maybe in China and USA, then it's not going to work.
Absolutely.
Okay. Another thing which is happening is the EVs are catching fire, which you would have realized. A lot of EVs catching fire. There are vehicles being recalled. There was a ship which was carrying a lot of cars, which also caught fire in the high seas. And the problem is you cannot use water to douse these fire.
Yeah. While the move towards EV vehicle adaptation is very clear, because it is coming out. If I look at some of the reports, the report says the Indian electric vehicle market was valued at USD $1,434 billion in 2021, and it is expected to reach to a level about 15,000 plus billion US dollars. But the industry is supposed to grow annually by about 47% each year. That's the forecast. So while there is a growth plan which is there, but I think these are as an industry expert, I think you're trying to basically sow the caution about where are the challenges, and I'm sure
where are the opportunities. The challenges and opportunities are both there.
Yeah.
But what I'm only saying is, there is a lot of scope for people to come in and work in these areas to mitigate these problems which the industry is facing now in this transient phase. So I'm not saying that lead acid should survive and lithium ion should not come in, or lithium ion is a wrong technology or something. What I'm only saying is, okay, that technology is progressing. This is also progressing. What are the opportunities in lead acid to make it more efficient? And what are the pitfalls which need to be addressed in terms of lithium ion?
Fantastic. I think that's a very good point. So, as an industry, I think we need to progress in both the technologies, because both the technologies are needed for the purpose of achieving the net zero emission level, not just for India but across the world. So more and more work has to be done with respect to research and development to make lead acid batteries more efficient, more better compared to what it has done so far. And obviously the lithium ion batteries have to become much safer to use. And the other area which we need to look at is how to make sure the
Recycle those batteries.
recycling of these batteries, whether it is lead acid or whether it is lithium ion, these battery recycling has to be done very, very carefully. Otherwise, we will create an environment maybe 50 years down the line, which is more dangerous compared to what we have today with respect to the carbon emissions, which is coming out from the conventional source of energy, which is the fossil fuel and coal. Am I right in this?
Yes, absolutely. Yeah. That is what I'm saying. In lead acid, you make it more efficient because recycling is not a problem. Availability is not a problem. In lithium ion, you have to think with respect to availability. So we have to use it efficiently only absolutely where it is required. And where it is not required, use the lead acid. And in lithium ion, look at ways of recycling efficiently, properly, in a manner that it is safe for the environment. So recycling has to be looked into, and safety has to be looked into, because safety is a matter of concern. So these are the two things: recycling and safety in lithium ion, and efficiency of all these operations in lead acid.
Fantastic. I think that's a good way to really conclude our discussion today. So the mission of becoming net zero emission has a major impetus to the investment in the renewable energy and associated activities. Batteries will play a major role in this journey. And Mr. Ramesh Natarajan, with over 40 years of experience in the industry, can really help our viewers and listeners with his expertise. Do reach out to him. Of course, I will share all his contact details about in the show note, and also I will share the details about the book, the wonderful book which he has written on the show note as well. So, Mr. Natarajan, thank you so much for sparing your valuable time to really explain about all related to batteries, not just I learned a lot of things from this conversation today, and I sincerely wish that all our viewers and listeners who are wanting to take up a career related to renewable energy as a broader goal can look at this as an important subject. So thank you, Mr. Natarajan. And would you like to say anything on the conclusion?
Thank you very much. And I'm here to help whoever wants to contact me. I also have a website, rameshnatarajan.in. So they can contact me through the website, or anyway from the details which you will be giving, my mail ID or whatever you will be providing. And thank you very much. That's all. Thank you.
Thank you so much. Thank you.
Right.